Hey YouTube, this is Brendan going over percent increase and decrease problems. Now, for percent increase and decrease problems, probably the best way to think about it is to use this equation. And this equation is going to tell you how to relate the final price to the initial price. So what we're going to say is the final price of the computer is going to equal to whatever the initial price is times 1 plus or minus r. Now, the plus is going to indicate when it's a percent increase, and the minus is going to indicate when it's a percent decrease. R has to be the decimal form of the percent. So if my percent change is 15%, then that means I'm going to use R is equal to 0.15. So let's go ahead and take a look at some problems and see how we can apply this equation in each of these problems. So the first problem that we're presented with is that a shirt normally costs $40. If that shirt is on sale for 25% off, what is the price of the shirt? Well, if the shirt normally costs $40, then we can see that 40 must represent our initial value. If the shirt is on sale for 25% off, well, that means that R must be 0.25. And since it's on sale, we know that the price of the shirt is going to be going down, so we're going to use minus. So what we're going to do is we're going to set up the equation final is equal to 40 times 1 minus 0.25. Now, 1 minus 0.25 is just going to be 0.75. So we're going to have 40 times 0.75, which is just going to give us 30. So the shirt, after all of these discounts have been applied, is just going to be $30. Take a look at another problem. So it's a very common adult problem. A customer receives a bill for $50. The customer wishes to tip 20%. What is the total cost of the bill? Well, before the tip is added, it's going to be $50, so that's going to be our initial. We're tipping 20%, so that's going to indicate that R is 0.12. And we know that we are adding the tip, so we know that our total bill, or our total cost, I'm just going to write this as T, is going to equal 50 times 1.2, because that's 1 plus 0.2. And when we multiply these two out, we're going to find T is equal to 60. So our customer's total cost will be $60. Here we're going to present a challenge problem. So a challenge problem might look intimidating, but really you're just using that same equation and maybe applying a couple of other concepts that are presented. So we have this guy Kyle, and Kyle's going out, he's trying to buy a computer. And Kyle knows that the sticker price for the computer is normally going to be $1,000. But Kyle's smart. Kyle found a coupon, and he found that with this coupon, he could take $100 off of that price. So right away, no percentages are going to be involved here. We're just going to knock $100 off so that we see that the cost to Kyle is going to be $900. But Kyle's even smarter than just finding the coupon. He knows that if he waits for President's Day or Labor Day or maybe Black Friday, he's going to be able to take an additional 20% off the price of the computer after that coupon has been applied. So what that means is this $900, Kyle's going to be able to take 20% off of that. And to do that, we're going to do 900 times 1 minus 0.20. If we think about what 0.20, 1 minus 0.20 is going to be 0.8. And then 900 times 0.8, well, that's just going to be $720. So right now, the computer costs $720, but anyone who's ever been shopping, unless maybe you live in Delaware or a state that doesn't have sales tax, knows that you have to pay a little bit extra on it, right? Uncle Sam has to get his cut. So we're going to have to take that $720, and what we're going to have to do is we're going to have to multiply it by 1.06. That's 1 plus 0.06, because 6 is a percentage, is going to be 0.06, and I'm just calculating that over here. And when we do that, we are going to find that the total cost that Kyle is going to end up paying is going to be $763.20. So that's going to be the cost to Kyle's credit card or debit card, or maybe he has cash. I don't really know. Well, thank you for watching. It's just a quick intro to percent increase, and percent decrease, and how you can apply those problems.